Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 12 of lesson number 11, work and energy. So in this part, I'm going to cover all the parts that are left so that in part 13, we can cover up with the summary and the exercise question because there are total 21 exercise questions that we need to discuss, right? So the summary part and the 21 exercise questions, I will be doing that in the next part, and whatever part has been left along with the activities and examples, I'm going to make you all study that today itself, and I'll be teaching you that today. Okay, so make sure you are clear with all the previous topics because I'm not going to give you much time for revision in this part. Okay, as like you have done revision so many times, so in this part I'm just going to show you the slides quickly, where you have to quickly have a glance through all the examples, everything that is that will be visible to you on screen. Okay, so you'll have to go through all of them. So before I proceed with this part, I want you all to quickly revise your notes. Okay, your notes, I'm giving you time to revise your notes, but screen I'll be showing you for few seconds, so make sure you're revising your notes thoroughly. Now this till now every one of you should be clear with all the concepts. I hope every one of you have started revising from your book. I hope every one of you all you all are going through the exercise question. See, make sure you know each and every concept and you're able to explain it, because that is going to help you a lot, right? So we have started the lesson by discussing on what exactly work is, because scientifically the definition of work is different, and like we discussed on not much work in spite of working hard. This is the subtopic that we studied, and here we had many different examples where we can exactly conclude whether the work has been done or not. Please go through it, everyone. Then after this we discussed on this activity 11.1, right? Then we had the scientific conception of work. So I want you all to please go through it as well. Then after this we discussed on this activity 11.2, right? Then we had this activity 11.3, and then we discussed on the work done by a constant force. So please go through it, everyone. Then after this we discussed on like one important statement is given on this slide, where they have stated that work has only magnitude and no direction, right? And the unit for work has also been given. So I want you all to please go through the slide, everyone. Then we discussed on this example 11.1, okay, where we had this, you can say, explanation over here. Then activity 11.4. After that, we had this example 11.2. So I want you all to go through it. Then we discussed on energy. So all the important parts, like which I feel, I'm stopping over there so that you can revise it. So make sure you're revising, okay? Then over here we have more explanation. So please go through it, everyone. Then we discussed on this activity 11.5. After this activity, we discussed on the forms of energy. So please go through it, everyone. Then we discussed about like Jane Prescott Joule. So I want you all to please go through it quickly as well. Then we discussed about kinetic energy in detail. So I want you all to please go through it as well. Then here we have the derivation for the same. I want you all to please go through it quickly, everyone. See, all the important slides I'm making you to revise, not all, right? So make sure you're going through it. Then after this we discussed on kinetic energy. So if the object is stationary, it doesn't have any kinetic energy, but if the object is moving, in that case it has kinetic energy stored in it, right? So this is what you need to know. Okay, then after this we had this activity 11.6, then 11.7, then we had this example 11.3. So I want you all to please go through it quickly. Then after this we had this example 11.4 as well. So please go through it as well, everyone. Over here, like through this example you have studied how to convert kilometer to meter, right? So make sure you know this conversion, because you can get some questions based on this where like you will have to convert it. Otherwise, like you won't be able to move further with the example unless and until, like, you'll not get the correct answer if you're not converting it, right? Then after this we had potential energy. Over here we have the definition for potential energy which has been given. I want you all to please go through it. Then we discussed on this activity 11.8, 11.9, 11.10. Okay, then we have 11.11. Then we had 11.12, and then we discussed on potential energy of an object at an height. So what kind of potential energy like we can have at a certain height, that can also be like we studied that over here, right? So if any object is at height, it means it has more of kinetic, and it will have more of kinetic energy in it, right? So I want you all to please go through this slide quickly. Then over here we discussed on like how can we derive like the derivation for the work done, that is equal to mgh, right? So please go through this slide, everyone. Then after this, here we had like the diagram based explanation that has been given, and I want you all to please go through it quickly. Then we discussed on this example 11.5. I want you all to go through this as well. So you need to go through the examples. The examples are very important. Then we discussed on like whether the various forms of energy that we have are interconvertible or not. So through this examples, we concluded that yes, the energy can be converted from one form to other, right? I want you all to go through the activity once. Then after this, we discussed on activity 11.4, and then I gave you some basic explanation on law of conservation of energy, right? So I want you all to please go through it quickly. Then over here we even discussed, like we need to discuss from here, right? See, when the object is about to reach the ground, that is when h is 0, b will be the highest, right? B means the velocity is going to be 0, right? So therefore, the kinetic energy would be the largest and potential energy, it will be the least. And for that reason, the sum of the potential energy and kinetic energy would be same at all points. What it would be? It would be same at all points. And for that reason, potential energy plus kinetic energy is equal to constant. And that is why we write this in 11.7 that mgh plus half mv square is equal to constant, right? So, the sum of kinetic energy and potential energy of an object is its total mechanical energy. Okay, so when it comes to finding out the total mechanical energy, it's equal to sum of kinetic energy plus potential energy. So, we find that during the free fall of the object, what will happen? There will be decrease in the potential energy and it will appear as an equal amount of increase in the kinetic energy. So the kinetic energy will increase and it will appear to be the same as potential energy. So over here, the effect of resistance on the motion of the object has been ignored. So we are ignoring the, you can say, resistance of the air, and for that reason we can say that the, if like, kinetic energy is whatever there is an increase in the kinetic energy, it's the same with respect to potential energy, because we are ignoring it, right? Because we are ignoring the air resistance. Then there is thus a continual transformation of gravitational potential energy. What kind of continual transformation has been seen over here? Gravitational potential energy is getting transformed into kinetic energy. Okay, I hope you all are writing the important points from screen. So now we have this activity over here. An object of mass 20 kg is dropped from a height of 4 meter. Fill in the blanks in the following table by computing the potential energy and kinetic energy in each case. What are you going to do? You're going to compute the potential and kinetic energy in each case. So for simplifying the calculation, take the value of G as 10 meter per second square. Okay. So the height has been given. Height at which object is located. Potential energy which is equal to mgh. Kinetic energy that is equal to mv square by 2, like half mv square, right? And then what we will do, we will like add on the potential energy and kinetic energy. So that is EP plus EK. Okay, now the height is given 4, 3, 2, 1. Now you have to like write the potential energy, kinetic energy, and then you have to add on to it. So I want you all to do one. Like I'll be telling you how to do it, but before that I want you all to start with it. The mass of the object is 20 kg and it's dropped from height of 4. Okay, so what will you do for this? Now for calculating potential energy, you need the formula is mgh. So you need mass, you need g, and you need h. G is acceleration due to gravity, right? So mass is 20, g is 10, okay, and then h is 4. So 20 into 10 into 4, when you do that, you get the answer as 800 joule. What answer do you get? 800 joule, right? And when you calculate kinetic energy for the same using the formula half mv square, so it becomes half into 20. M mass is 20, right? And what is v? Well, initial velocity is 0, so 0 square. So what will be your answer? 10. 10 into 0 is 0. So your answer will be 0 joule. So when you add 800 plus 0, you get the answer as 800 joule. Got it? So this is how you need to do. Now in like at height 3, you will do the same thing, but over here you will have to find the velocity. So we know that the initial velocity is 0 and acceleration due to gravity that they have given, that is a is equal to g, is 10 meter per second. And what is the distance traveled? From 4, the distance has like the distance traveled by the object, it comes to 3. So 4 minus 3 is 1, right? So now you know u is 0, right? And s is 1. So we will use the third equation over here, that is v square minus u square is equal to 2as. And when you calculate that, you will get the answer for v square, that will be equal to 20. And then again you need to apply the formula mgh and half mv square. Okay, but before that you have to use the formula v square minus u square is equal to 2as. Then when you use this formula, you will get the value of v, and then only you will be able to calculate the kinetic energy, right? So please calculate it for 3, 2 and 1 everyone, and then we'll proceed with the next part. I hope you all are calculating the values for this potential energy, kinetic energy. Once you calculate that, we need to add on to that. Okay. Now the next thing that we have is rate of doing work. Now at what speed you're doing the work is like your rate of doing work, right? So do all of us work at the same rate? Like suppose you are writing something. So for writing the same thing, you will need 5 minutes, but your friend will need 10 minutes, right? It means the rate of doing work was different between you and your friend, because of which you were able to do the task earlier as compared to him. This is what rate of doing work is. Okay. So do machines consume or transfer energy at the same rate? What do you think for this? Like when the machines work, are they consuming the same energy? And when they are consuming the same energy, are they even transferring that same energy at the same rate? And agents that transfer energy do work at different rates. So machines are obviously transferring energy, right? So whenever this transfer of energy takes place, and whosoever the agent is, whenever the agent transfers the energy, it does work at a different rate. So let us understand this from the following activity. So we have this activity and examples that we will be discussing on. Like I might stop over here after discussing the activities and examples. Okay, so we have this activity 11.16 over here. Consider two children A and B, and let us say they weigh the same. Okay, they both weigh the same. After that, both start climbing up a rope separately. What they started doing? Both of them started climbing up a rope separately. Okay, now both reach a height of 8 meter, and let us say A takes 15 seconds while B takes 20 seconds to accomplish the task. How much time has been taken by A? 15 seconds, while B is taking 20 seconds. Okay, for doing the same task. So what is the work done by each? Okay, you have to find that, like like how much amount of work is done by the child A and the child B, and the work done is the same, right? Because they are accomplishing the same task. It's just that the time taken by both of them is different, right? However, A has taken less time than B to do the work. So who has done more work in given time? Say in 1 second. So how will you find out, like what kind of explanation can you give over here? And they have asked you to calculate the work done in 1 second, right? So both the child, they are climbing up, means they are doing the work, and the work done is against the gravity because they are climbing a rope. So the work done is against the gravity. What is the formula for work done? mgh. Potential energy is mgh, right? Now they have stated that both weigh 25 kg, right? Let's say that Both the child weighs 25 kg and work done by child A will be mgh. M mass is 25, G is 10, and height is, what height are they traveling? Let's say they are traveling like 8, okay, 8 meters, a height of 8 meters. So you get the work done will be 2000 joule. Work done by child A is 2000 joule. Now we'll calculate the same way for child B. mgh. M mass is going to be the same 25, G is going to be the same 10, right? So you have to calculate that. And what another thing that you need to calculate over here, so work done by both the child is same 2000 joule. When you calculate it using the formula mgh, you will get the same answer, that is 2000 joule. Now we need to calculate the rate of doing work, that is known as power. So we represent P is equal to W upon T. So work done is 2000, time taken by the first child is 15. So what you will do, power is equal to work done upon time taken. So work done is 2000, time taken in 15 seconds. 15 second by the first child. So you will get the answer as 1333 watt. And child B, 2000 divided by 20 will be 100 watt. So who has done more work, like more work? The power of child A is more than power of child B. This is what, like, you need to explain through this activity. This is going to be the conclusion for your activity. Okay. So you are using one of the formulas mgh for calculating the amount of work done, that is potential energy, and then you are finding out power, that is equal to work done upon time. These are the two things that you need to figure out. Okay. I hope you all are writing it. So we have an explanation for this. See, a stronger person may do certain work in relatively less time, and a more powerful vehicle will complete a journey in shorter time than a less powerful one, right? Let's suppose I'm traveling through a train. So like train is going to take a shorter time, like shorter span of time to reach a certain destination. But if I take my bicycle, like it's very obvious that because it's less powerful than a train, it is going to take more time, right? So we talk of the power of machines like motorbikes and motor cars and the speed with which these vehicles change energy or do work, that is the basis for their classification. So over here, their speed is their basis of classification. Okay. So power measures the speed of the work done. That is how fast or slow the work has been done. And that is why we can define power as rate of doing work or the rate of transfer of energy. What is power? Rate of doing work or rate of transfer of energy. Okay, and if an agent is doing work, that is W in time t, then power is equal to W by t, that is work upon time. What is the formula for power? Work upon time. So the unit of power is watt in the honor of James Watt, that like in the year he was born in 1736 and he died in 1819. They have the symbol W. So Watt has been like named in honor of James Watt. And what is the power of an agent which does work at the rate of 1 joule per second? So over here on this slide, we have the definition for power and we even have the definition for watt and on whose name like what has been like used as the unit of power has also been given, right? So we can also say that power is 1 watt when the rate of consumption of energy is 1 joule per second, right? So 1 watt is equal to 1 joule per second, and we express the larger rates of energy transfer in kilowatts. So if the energy transfer is more, like in higher like if the energy transfer is taking place at a higher rate, then it is expressed in kilowatt, and 1 kilowatt is equal to 1000 watts. Okay, so 1 kilowatt is equal to 1000 joule per second. So the power of an agent may vary with time, and this means that the agent may be doing the work at different rates at different interval of time. And therefore, the concept of average power is useful. So we can calculate average power by dividing total energy consumed by the total time taken for it. Okay. I hope you all are writing all the important points. I hope you all are writing all the important points from this slide. Now after this we have this example that I'll start in the next class, and then we will be even discussing on commercial unit of energy, which is a very short part, so we'll be easily doing it in the next part. And then we have the summary discussion for the lesson work and energy, and after this we have like 21 questions to discuss in the whole lesson, right? So in every part I show you the 21 questions that we have, and I want each one of you to please go through the questions quickly. I hope every one of you are going through the slide. Like you need to know all the questions, like at least the question should be in your mind so that when you are answering it, you know what all points you need to include in the lesson, right? So this is the last question that we will be discussing at the end of the lesson, and like we are just left with one more part for the lesson, so everyone make sure that you all are going through whatever we have studied so far, because it's very important for you to know what we are studying, right? So now I'll be ending up with this part, and as I said, please revise each and everything that has been discussed so far. Okay? So I'll end up with this part. Thank you everyone.